Okay, partitioning a segment. Really partitioning a line segment, just for being a little more accurate. So the first thing you should do is understand what's being asked of you. So partitioning a line segment, we want to find C such that AC to CB is in the ratio of 1 to 3. All right. So that means 1 part to 3 parts. I'm kind of going to go through this in a way to help you more understand it. So if I just want to think about that line, I want to break it up so that I have 1 part somewhere over here, and then I have kind of this 3 parts. So I have 1 part here, and then I have 3 parts on this side, right? And if you look, I have these 3 sections from here to here, and so C is going to be somewhere around here. Now this is an approximation, but we can use some calculations to be exact. So now this is just the idea. I have these 3 parts right here, and this 1 part right here. That's the idea. So how do you go about doing that? Well, this would be an ordered pair, and this would be an ordered pair, and so we're going to use the relationship of the ordered pair distances to kind of figure out where we should be. So if I'm 1 part to 3 parts, there are a total of 4 parts, right? And so I am going to use a fraction of 1 over 4. So I have 4 parts total, and then the numerator is how far you travel. So it tells me 1 part to 3 parts. So AC, right? AC, this would be kind of my AC distance, is the length of 1 part. So if I want to know the length of AC along this line, I know it's going to be 1 part out of 4 parts. Okay, so I'm going to travel 1/4 the length of AB to get to AC. So we can say that if I want to travel 1/4 of AC, I will arrive. I'm sorry, 1/4 of AB. I apologize. It's normally I put it alphabetical order, but 1/4 of AB, I'll get to AC, right? AC is where we'll end up. All right, so now we're just talking idea. Now let's do the math, right? So I know that the way to think about it is that I'm going to travel, you always travel horizontally and then travel vertically, right? Ordered pairs. So I'm going to go some x distance and then my y distance. So that x distance I'm going to travel, of course, I want to go 1/4 horizontally, right? So maybe 1/4 here, that might be 1/4 of this line, and then I want to go 1/4 up, right? So what is the distance? If I think about this horizontal distance, what is my x distance? So I need to figure out the x distance. And I'm going to go 1/4 of that, right? So my x distance is just x2 minus x1, right? Or 5 minus -3, which of course gives me an x distance of 8. And so I'm going to travel 1/4 of that distance, right? So I'm going to say 1/4 of 8. Make that 8 a little nicer. It's not a very nice 8, but whatever. 1/4 of 8. So I'm going to travel 2 units horizontally to the right. Now it's important that because I'm going to the right, my travel is +8. Okay? If I was going to the left, like if I was starting at B and going to A, I would be -8, just kind of clarification purposes, because that's the distance horizontally to the right, +8 units. And then my y distance, right? My y distance is, well, y2 minus y1, right? And so it's 5 minus 1. So that would be 5 minus 1, which is 4. And I'm traveling still 1/4 of that as well, which gets me 1 unit up, right? So where is my location? Ultimately, I want to figure out where I traveled and how I got to that location. So we're going to approximate the location C being here. But how do I figure that out? Well, I have to go from my starting point. So 2 units added to starting point, right? And that would be the same thing over here. 1 unit added to starting point. And what is the starting point? Well, x1 and y1 are my starting locations, right? If I'm coming from A, my starting point would be, starting point is -3. And if I'm also coming from A for y, my starting point is +1 because that is x1 and that is y1. So what do? I take the 2 units and I add -3, right? So I would have 1/4, which is my ratio, times my distance, right? And then I am going to add my starting value. So I end up with 2 minus 3, which tells me that I am at -1, which is about that location, right? So this location here is -1. And then my y values, right, it's going to be starting at 1, right? I have 1/4 times 4 plus 1, which is 1 plus 1, which is 2. And so this location right here would be 2 vertically. And so the location of my partition segment, we could call that x partition, comma, y partition, whatever you want to call it. It's really flexible. But just for the idea, it would be -1, 2. This location is 1/4 of that line, right? So it's just 1/4 of the horizontal, 1/4 of the vertical. So we can generalize a rule that will work every single time for any of this. We can take the ratio of the partition times the distance, and now it's important that we use the direction of that distance. So if we are going negative, we will, so like if I was going from B to A, I would have to say it's -8, right? And then also down -4. So that will be important for when we do go in those directions. So we don't need to worry about that right now, but then plus the starting point. And if you use this, right, and we can simplify this till we can abbreviate ratio as R times the distance plus the SP. If we wanted to kind of simplify our formula to just letters, that formula works every single time, but we do have to take into consideration that that distance could be negative because it's got a direction. All right, and that is partitioning.